Welcome to EDU World Space.
Okay, so this is the force diagram for block A. Since the spring is unstretched initially, therefore the spring force should be equal to 0. So now let's assume that block A is about to slip. So since it's about to slip, that means it's still in equilibrium. Therefore, the net force along the xy direction should be equal to 0. So we have Fx is equal to Fa minus Wa sin theta is equal to 0. So Wa sin theta is equal to Fa. Wa here is the gravity of the block A, and Fa here is the friction on block A. And on y direction, we have Na minus Wa cosine theta is equal to 0. Therefore, Wa cosine theta is equal to Na. And we know friction at point A can be equal to mu A Na, which is equal to mu A Wa cosine theta. And then we know Wa sin theta can be equal to mu A Wa cosine theta. As you can tell, since both sides have Wa, therefore Wa can be cancelled out. And this will give us sin theta is equal to mu A cosine theta, which means that sin theta over cosine theta is equal to mu A. So we have a tangent theta is equal to 0.15, since mu A is equal to 0.15. So now we can determine angle theta, which is equal to 8.53 degree. Now we can determine the friction on block A, which is equal to mu A Wa cosine theta, and this is equal to 0.15 times 10 pound times cosine 8.53 degree, which is equal to 1.48 pound. And then this is the force diagram on block B. And assume that it's in equilibrium, so if Fb minus Wb sin theta is equal to 0, and we'll have Wb sin theta is equal to Fb. Wb is the gravity of block A, I'm sorry, not block A, block B. And then Fb here is the friction on block B. And then on y direction, we have Nb minus Wb cosine theta is equal to 0. So if Wb cosine theta is equal to Nb. And Nb here is the normal force on block B. And then we know the friction on block B can be equal to Wb sin theta, which is equal to 6 pound times sine 8.53 degree. And this is equal to 0.89 pound. So now we know the maximum friction at point B is the static friction at point B, and this is equal to mu B Nb, which is equal to mu B Wb cosine theta, since Nb can be equal to Wb cosine theta. And if we plug in the values, eventually you have the maximum friction at point B, or in other words, at block B, is equal to 1.48 pound. As you can tell, the friction at block B is less than the maximum friction on block B. Therefore, block B does not slip. And these are the answers for this question.